Let's go on to the next one. 79 word search. Given an M by N grid of characters, board, and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells. So it's four directional, up, left, right, and down, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once, so we can't double back. So this is like word search. When we used to do these as kids, look at example 1. You have A, B, C, C, E, D. Now that's not any word that I know, but you can see in the input you get the board, and then you get the word, right? So the word is A, B, C, C, E, D. And what it looks like is you want to check off all these letters, right? You want to check off all the letters, and once you check off every single letter, you have a found word. Okay, so let's think about how this works, right? Even mentally, when you're doing this yourself, in a regular word search, you find a specific letter, right? Let's say we get to the letter A, and you look in every direction. You look down, right, up, left, and from that A, you may find something that matches what you're looking for. You find a B, right? And actually, this A, when you go up and left, you go out of bounds. So you're going to make sure you don't keep going out of bounds. Now, you get to this B, and what does that tell you? By the time you get to the B, you've actually, internally in your head, you probably matched an A, right? This A, let's go ahead and make that green. He's out of bounds. Let's go ahead and make that red. Now this A you've already matched, right? And now you get to the B. Now is B what you're looking for? B is one of the letters that you're looking for. Let's make that B green right there. Now you can go in many directions. You can go up, right, down, and back left. Now, this is also out of bounds. Now, do you want to go left? Probably not, right? The same letter cell may not be used twice. So, what do we know about this? How do we keep that type of information? We can create a visited set, and that set can have something like the coordinates. So what is A? A in our example is the first row, first column, right? So A is 0, 0, position 0, 0. So if it's in the visited set, don't go there, right? Also don't go there if it's out of bounds, and we can continue. Now B goes to C, right? But we could have also easily gone down. Down is F. F is not a match, right? So at any point, if we figure out that it's not a match, we can exit out of that scenario. So we go to C. C matches, and I think you could see where this is going. You keep going until you find the match, right? So you find this C, you find an E, you find a D. What you're finding is C, C, E, D, and at that point, you have a match. So, a skill that you're going to need in this one is you're going to need to iterate through a grid, right? Uh, a list of lists, but we're going to call it a grid or a matrix. And then for each grid or matrix, you're going to start this kind of traverse word function, right? Let's say it takes I and J. And traversing the word is doing this checking off process. A, B, C, E. This not word. So let's move this down so we don't see the notes. And we're going to build this, right? So what we need to build is a couple things. Let's build some helpers. And let's create a go function. And let me put this go function in here first. We're going to traverse, right? And this go function is going to be, I'll call it find word, right? And this is going to be our recursive function. And a traverse function, If we do find the word, then let's exit early, right? We don't have to keep searching. We can exit early. Otherwise, we return false, right? And exit early means returning true, right? So we're going to return true, exit early. Now, what is our find word function? Well, just like we saw here, we're going to do an out of bounds check. Well, first let's talk about the arguments. What arguments should we use for find word? We can use some indication of where we are in the word, right? So maybe like a word index, something like that. Where in this word are we? All right, we do an out of bounds check. What other checks do we need? We can do a visited set check, right? We need to do that. I'm going to put the word check first, check out of bounds. We're going to check our visited set. We need to check if this current letter is valid, right? So valid letter. Let's check if current letter is valid, right? Or let's say if we want an early return, then we want to check if the current letter is invalid, right? And then what do we want to do? We want to recurse. We want to go in 4 directions, right? And what we can do here is 4 directions. If we find it in any one of these, we return, right? So the result is equal to, going left. I'm gonna say recur here, but recur top, bottom, right, and left, right? And what is our return value? Our return value is either true or false. Okay, perfect. Now, where do we want to put our visited set? This is a question. Do we want it in here? Could put it in here. So let's go. So let's do traversal, right? We can start here. So let's do our helpers, right? What are helpers? For grid questions, I always like to say n rows equals this. That's how many rows there are. Columns equals this. That's how many columns there are. N letters. We can say that as well. And that's the length of the word. And cool. So we're going to use those helpers in the future. Now let's traverse. Traversing a grid is quite a fitness exercise, as in you should practice this until it becomes very natural to you in your language, right? So for I in range n rows, for j in range n calls, then ij here is my row and my column, right? And I'm going to call that traverse function. So find word. I guess find word actually needs a row and a column. So we're going to call that ij. And do we have to? Yeah. We have to do if find word. If we do find the word, then we want to return true out of here, right? Now, what is the index of the first letter? Let's start it at 0, right? At the 0th index, the letter of the word. And a visited set, let's just go ahead and pass in a set here. Now, at the end of this, if find word never returns true, let's return false out of this function. Okay, let's do some out of bounds checks. Right, so if row is smaller than 0 or row is larger than or equal to n rows, then let's return false out of here, right? Column is smaller than or equal to 0 or column is larger than n calls, let's also return false, right? Let's check the visited set here. So what's the value, right? The value here, or the letter, let's call it, is at this board, at this row, at this column, this is a letter, right? We're inbound, so we know that we should have a letter. If the letter is in the visited set, well, then we also want to return false, right? Because we don't want to double back. No double backing. Now, what if the letter is not what we're looking for? Okay, so if the letter is not equal to the letter that we're supposed to match, and the letter we're supposed to match is word at this index, then we also return false, right? So, you know, in our example, if you went from, sorry, that's kind of messy. If you went from this A, right, this A right here, if you went from this A to this B to this F, well, this F is not matching, right? So we want to return false there. Okay, now, there's two ways to do visited here. One way is we can do that backtracking. We can add to visited set. We can take it out. I don't know if that's necessary here, but we can do it. It might be an optimization. We can do that later. Now, for the result. Now, the result that we're returning is the result of going in all these directions, right? We're going to find word, and we're going to go row plus 1, column, index plus 1, and we're going to pass in the visited set, right? So that's going up. This would be going down. Let's do an OR here, actually. That would be going down. Let's go right. That would be going right. And this would be going to the left. Okay, so we're passing visited set here, and I see where it can go wrong. In every direction, we're mutating visited set. And that's where it can go wrong. Every time we call find word, we want to be able to pop out what we're doing from the visited set, right? So let's say I'm going to call this result. I'm going to add the current letter to visited set, right? So at this point, the letter is not in visited set, or it would have returned here on line 17. So visited set, add letter, right? And here I'm going to do visited set, remove letter, and return result. So that's that backtracking flow. Okay, we don't need that last OR. Oops, I just sent it. Do we have the right, I see. I see. If at no point here I actually return true. So we still need to handle our base case, and we still need to return true at some point. Now, at what point do you think we should return true? Let's see. Checking out of bounds here, visited set. So we're going to start at 0. It's right here. We're going to start at 0. 1, 2, 3, 4. We're going to reach a 5, right? And actually, at this point, we have a letter match, and possibly we've already finished, right? Possibly we've already finished. How do we know if we finished? Well, the index is going to tell us that. When the index is 5, it's going to tell us that. Now, what's the length of this? The length of this is 6, right? So, if the index is the length of the word and letters minus 1, then we're finished, right? We actually have the correct word. We can actually return true from there. We don't need to do this iteration. Let's run this and double check. I did mean end letters. Thank you. And now we have the output is true, but we expected false. Interesting. So what does that tell? That tells me that I am not incrementing. You see this? I'm just passing in find word. It's a function, but I'm passing it as some type of list of arguments or something. I'm not even calling find word. I'm surprised any of the code even works, to be honest. I should be calling this recursively. There we go. Let's run this. Is this correct here? No, I didn't even think it worked before. But is this correct? Let's see. Results here. It's find word. It's going up. Well, this one's up. This one's down. This one's right. This one's left. Okay, perfect. And those are columns. And the index we want to increment by 1. Perfect. Visited set is here. And then if we do find these words, we're going to start at 0. So this makes sense. This makes sense. And we want to think through, what is visited set doing? Passing visited set through. I'm removing the letters when needed. Perfect. Checking out of bounds. This is board at this row column. Perfect. If it's in there, perfect. If the letter is not matching this, return false. Great. If the letter is equals to n letters, at this point it matches. I want to return true. Perfect. What is my error here? Traversing. I wonder what A, B, C. Is it this parentheses? I should be printing more than that. No, maybe I need the parentheses. Yeah, I should be printing more than this, right? Because ABC, and it should be doing the letter check. Let's do it up here. A, S. S is not it. B. Okay, so index 2, it should be matching on C. Index 3 should be matching on the other C. Where's index 3 at? There should be an index 3 at the other C. Oh my god. Okay, so I see the bug. I'm putting letter into visited set, and that's wrong. Visited set is this. Positions. I don't want to go back to the positions. Right? So the position is, let's call it row and column. And the position is what I don't want to revisit, right? So I can definitely have two C's in a word. If the position is in the visited set, I should have referred back to the diagram, then that's wrong. And what I'm adding is the position. Every time I see visited set, it should be the position. It should not be letter at all. Easy to make a bug there. It's actually the position. I don't want to double back, right? From this B back to the A, I don't want to double back. That's the main problem. That double backing problem. Okay, let's try this. Awesome. Am I printing anything I don't need to print? Doesn't look like it. Let's submit. See how it goes. I'm surprised I passed so many test cases. That's funny. All right, so there we go. Got a pretty decent runtime, um, decent memory. I wonder if we could have done the backtracking. It would have been faster. Definitely, it might have taken less memory, but I'm happy with this. This is the crux of the problem, and it handles all the cases. Thank you so much for bearing with me in this debugging process. This was a test. If you saw that position should have been in visited, then you passed the test. Thank you so much. I will see you next time.